the parabola opens up. What that looks like is essentially a U shape. If the leading coefficient is negative, the parabola opens down. I think about that as like my emotions. If I'm thinking positive, things are going up for me. If the leading coefficient, the start of this function, is negative, things are going down. The vertex is the lowest point of a parabola that opens up. So that's right here. Can you please make that note right there that that's a vertex? It's also the highest point of a parabola that opens down. So here's the parabola that opens down. That's the highest point right there. The line passing through the vertex that divides the parabola into two symmetric parts is called the axis of symmetry. Now, Mr. P's parabolas that he made over there aren't the prettiest things, but you'll notice that if this were drawn correctly or accurately, this right part folds onto the left part, or vice versa, that there is symmetry there. It's kind of like a butterfly. Right down the center of the butterfly, the left wing folds onto the right wing, and it looks exactly the same. Same with parabolas, even downward, or parabolas that face down. Now that one got a little bit away from me, or maybe it should actually look like the left side over on the right side. It should be symmetric. Solutions of quadratic functions are also called the roots or zeros. Here's a graph. So back in the day, this was pretty cool that we could create quadratic equations, and I guess right now could be a good time to look at the fact that if you look at the vertex, the bottom part of this graph, it's not always right on the x-axis, or the y-axis, excuse me, or the x-axis. It moves around depending on the function. And sometimes it opens down. So I'm going to change the x squared term here. I'm going to decrease it. If there is no x squared term, it's a linear function, so it's a straight line. Now let's make a negative x squared. Notice how now it's a downward facing or opening down parabola. So here we have -2, 4, -9 as our a, b, and c value. Well, I kind of got excited about this. Our goal here is to find the vertex and axis of symmetry for these quadratic functions. So to do that, we're going to put the quadratic function in standard form. So y equals ax squared plus bx plus c. Then we're going to identify the coefficients of each of those three terms. A is always the coefficient of the x squared, b is the coefficient of the x, and c is the constant. So a is -2, b is 4, c is -9. Now to find the x coordinate of the vertex, we're going to take the opposite of b, and please write that in your notes. This shows up on the bottom of these examples. Write that negative means the opposite of b. So when I get you in geometry, you're going to use a lot of subscripts because you're going to have a lot of parts of shapes and whatnot. So you'll use subscripts quite a bit. So v is for vertex, x is for the x coordinate of the vertex. I'm finding the x coordinate of the vertex. So I take the opposite of b divided by 2a. So the opposite of b is -4. Because b is 4, so the opposite's -4, divided by 2 times, it's always a 2 right here, times the a value, which is -2. So that equals -4 over -4, and that's the same as +1. So that's the x coordinate of my vertex. So for a vertex, I can put a 1 in for x. By the way, the axis of symmetry is going to be a vertical line, which means it's going to be x equals, and it's going to be whatever that number is we just calculated, the opposite of b divided by 2a. So right now I know the axis of symmetry is going to be x equals 1. And I'll show you what that means here in a bit. I'll give you a visual for all of this so it makes a little bit more sense. But right now, just trust what we're doing. So not today, but in the future, we will be graphing these by hand, and we'll also be using some technology, but we need to be able to do this by hand. So the x value is 1. Now when we used to graph linear functions, we always put our starting number, which was usually 0, right in the center of that table. So a little space above it, some space below it. We're going to keep doing that. Our input that we're going to start with on this table for a parabola goes right there. And so now everywhere I see an x, I'm putting a 1 in place of that. And make sure you put parentheses around what you're substituting in. So negative 2 times, not x, but negative 2 times 1 squared, because I'm still squaring whatever that x value is, plus 4 times 1 minus 9. Use your calculator. Make sure you use parentheses. If your phone, if you're using the calculator on there, is not giving the right answer, sometimes it doesn't know the order of operations, or the negative buttons kind of work backwards. You're always welcome to use one of my calculators. You should get, let's see here, should be getting 7 on this one, I believe. So the y value, when x is 1, y is 7. So let's try this. I'm going to go to Desmos. So that's www.desmos.com. I'm going to start graphing. And I believe it was y equals negative 2x. There's a squared feature down here. Plus 4x minus 9. And we thought the vertex was at 1, negative 7. It sure is. Look at your scaling. 1's right in the center between these two darker lines. So that's 1, and then negative 6 and negative 8. Negative 7's right in between it. So hey, the vertex, the top of this downward facing, did you know it was going to be downward facing? Parabola is at 1, negative 7. And if I were to draw a vertical line right here, notice the left part is symmetric to the right part. So this is my line of symmetry. Because it's a vertical line, if you think back to vertical lines, the word vux, the slopes are undefined, and it's going to be an x equals equation. The equation of this line is going to be x equals 1, which again was my opposite of b divided by 2a work. All right, pretty sweet. Let's try another one. I'll move this over to the left. Here's our next function. Notice it's written in standard form. It's written in standard form. Let me just keep that stuff that I highlighted there for a second, then I'll erase and move it. So identify the a, b, and c value. So a is 1. There's a 1 in front of that x squared. Wait a minute, there's no x term. Huh, so then it's 0. There's 0 x's there. And my c value is negative 10. So I've identified a, b, and c. Now the vertex has an x coordinate. So vx, v sub x equals whatever the opposite of b divided by 2a is. Well, the opposite of 0 is like negative 0, but we don't need to, so I'll throw a negative there just if you want me to. But negative 0 divided by 2 times 1, because a is 1. So we get 0 divided by 2, or negative 0 divided by 2. That's still going to be 0. So my x-coordinate is of the vertex is 0. And then I also know that my axis of symmetry, so at 0, is going to be x equals the number I just calculated. So x equals 0. But we need to figure out what y is. So making an input-output table, we're going to input 0 for x and calculate what y is. So 0 squared minus 10. And you'll get negative 10. So we'll have an upward facing parabola with a vertex at 0, negative 10. Let's see how that works. Let's go back to Desmos. And I'd encourage you guys to practice with this. You got to know how to do this skill, how to manually calculate this stuff, but then check your answers using Desmos. Sure enough, the vertex is at 0, negative 10. And if I drew a vertical line right through this, it creates an axis of symmetry. and that's at the line x equals 0. All right, let's try 2 more. So identify A, B, and C. This is already in standard form. So A is 1, B is 4, C is -1. The x value of the vertex is going to be the opposite of B. So that'll be -4 divided by 2 times A. A is 1, so 2 times 1. So we get -4 divided by 2. That equals -2. So we know that's our x value, -2, and the axis of symmetry will be x equals -2, a vertical line going through all the -2's for x. So input-output table, we know what x is for the vertex. We know that we go left 2, but how far up or down do we have to go? So when I put in -2 to this function, what do I get? Make sure you use parentheses around what you're substituting in, folks. If you don't here, because it's a negative, you'll get the wrong answer on your calculator. And here, I believe you should get 11. I did that in my head, so I could have screwed that up. It seems right. I'm pretty sure that's right. I'll grab a calculator here, or I'll go to Desmos and just make sure that's right. And if it's not right, I'll recalculate it. So that was y equals x squared plus 4x, and then I forgot the rest, minus 1. That's not good. Oh, so we got -2 and 7. So where did Mr. P make a mistake? Four plus 8 is 12, minus 1 is 11. Oh, did you guys catch this? Bessie, x is -2. X is -2. I plugged in a positive 2 there. So if we do this, we get -2 squared is 4 plus -8 minus 1. 4 minus 9 is -5. Oh, good thing we checked on our graph just to, or if Mr. P would have, actually a calculator would have helped there, folks. I substituted in wrong. Sometimes we copy wrong, right? So was that -2, -5 then? Yep, there we go. -2, -5 is our vertex. And then our line of symmetry would be a vertical line through -2. All right, well, that was embarrassing. So we'll all learn from that, right? Be really careful with what you're plugging in. All right, let's try this again. This one's in standard form. So A is -2, B is 8, C is -8. So then the vertex value is going to be the opposite of B, so -8 divided by 2 times A. So we get -8 over -4, which equals +2. So our